In today's video, we're going to see how we can implement dynamic routing on top of the base topology that we created in our last video. If you haven't seen that video, a link would be provided in the description, so you can watch how we created this topology. A brief overview will be that we have three VLANs on each site, that is site A and site B, which we named campus A and campus B. And the whole purpose of this exercise is to implement dynamic routing and connect these two sites. So we have three VLANs, VLAN 10, 20 and 30, and the same VLANs are in the other side, that is 10, 20 and 30, but we are using different network IDs. For example, on site A we have 10, 20 and 30, and on campus B or site B we have 40, 50 and 60 network IDs. Okay, so we will be using a class C series 192.168 dot series. So the maximum number of hosts, as you know, are 254, the valid count. So we will try and implement dynamic routing and connect these two sites together. Right now we can ping this internet router, and we already have, as you can see, we have VLANs, and then on top of that we have DHCP, and then NNAT is also implemented to connect these private IPs to this internet router via translation from private IP to the public IP. So if we try to ping the 8.8 router, that is our internet router, we are able to ping. And the same way, if we try pinging from another device from the second side, that is campus B side, we are able to ping it. So but if we do the same and try to ping any PC, for example, if we try to ping the same PC, that is this one, let's check the IP, and the IP is 50.2. okay, so if we try to ping 192.168.50.2, we won't be able to ping it right now because the sites are connected but there is no routing available. So as we have seen in our previous videos, in which we already implemented static routing and dynamic routing using different protocols. So we know that whenever we have to ping another site or another network or that is connected to a different router, we need to have the routing entries present in our routing table. So if we see in our routing table on campus A router, we only have 10, 20 and 30, that is the directly connected IDs to our router. Okay, and the same way we have 40, 50 and 60. Yeah, there you go, we have the 40, 50 and 60 network ID that is also directly connected to the campus B router. So right now there's only direct connection, and there are no routing updates being exchanged, or there is no static route other than the 8.8.80 static route that we created in our previous exercise to connect this private IPs to this internet router. Okay, so what we have to do is we have to implement dynamic routing. The protocol that we will be using is EIGRP. We have selected EIGRP because it will automatically revise how to do routing using RIP and also OSPF, because as you remember that there are multiple ways in which we can advertise routes in EIGRP, and they resemble RIP and OSPF advertisement. So we will be using a mix of both those methods, so that at the same time we implement dynamic routing and also revise how to advertise using RIP and OSPF. So let's start, and let's start from router A. So what we have to do is we have to go to the global configuration mode, and then we have to activate our routing protocol. that is EIGRP, and then the autonomous system ID. And the next is pretty simple. We just have to advertise 168.10.0, advertise our network IDs that are directly connected. So these are directly connected, and one thing that we need to ensure is that the network ID of this interface, that is fast Ethernet 01, is a must to be advertised, because if it's not advertised and we advertise all the other network IDs, it will not exchange routing updates. So this is a must, and the network IDs of course should be exact. If we advertise a different network ID that is not present, it won't work either. So first I am going to use the method that is used in RIP. So the first three entries I'm going to do using RIP protocol method, and the last entry, that is we advertise this network ID. This is the connection of our site A to site B, or campus A to campus B router. Okay, so that I will advertise using OSPF method. And in OSPF, if you remember, 1.1.1.0, that is the network ID, we use wildcard mask. So this is a /30 network, so that means only 2 bits are available, and if we calculate the maximum number of hosts that are available in a /30 network is 4. So if we would write the wildcard mask, it would be like this: 0.0.0.3. That means that from 0 to 3, this is the range of IPs that will be available. Okay, so that should do it, and let's save, and let's do the same on the other side. So let's go to router B, go to global configuration mode, and then activate our routing protocol. And next step is advertisement, and advertise the directly connected routers. That is, here we have 40 ID and 50 ID, and the last one is the 60 ID. And the most crucial one, we have to advertise the ID that is connecting these two sites, that is fast Ethernet 01. So network 1.1.1.0 and 0.0.0.3. Again, I'm using the method that we use in OSPF, and the first entries were done using the method that we use in RIP advertisement. So there you go, and as soon as we do that, we can see that the neighbor agency is formed. We have a message, and hopefully when we try to look up the routes now, we will have the routing table. Yeah, there you go, we have the routes exchange 1030, 1020 and 30 are here through the exchange done by DHCP. So let's verify the same on the other router. Here we can see the same message, and let's verify the routing table, and there you go. So we have the 40, 50 and 60 network IDs exchanged by EIGRP after routing was done. So now let's try and ping the same PC again. For example, this was 50.2, and there you go. After the routing was performed, we have the network IDs present in both our routers, so our ping would be successful. And the same way, if we want to ping another network ID, that is 40.2, the first would be the ARP packet loss, but the others should go through, and that's okay. Another successful. And let's try the last network ID. Same would be done here. The first would be timed out, but the rest would go, and there you go. So that's how we can implement dynamic routing. This scenario that was running VLANs, DHCP, NAT, almost all the things possible in a standard basic network. So this is the first scenario of multiple scenarios that we will be making in this topology. So until next time, take care.